The other day I bought a mixed nut can and suddenly started wondering, can I count each nuts in the can without really counting them all? Well, I explored that question in this video. Let's find out. I started by taking random samples, each sample containing roughly about 15 nuts. It's best to keep the sample size uniform, but to avoid visual bias, I decided to just fill up the cup to a predetermined height instead of counting 10 or 15 nuts at a time. I took a total of 37 samples. The average of the nuts of all the samples is 15. Once all the samples were collected, I tallied each type of nuts present in each sample. Because I didn't have a sensitive enough scale, I didn't measure weight of individual nut categories in each sample cup. Rather, once the count was tallied up, I started taking a weight sample of individual nuts in groups of 5 nuts at a time for almond, 1 nuts per sample for hazelnut, 10 nuts per sample for peanut, 1 nut per sample for pecan, and 5 nuts per sample for cashews. Once enough sample weight was taken, I took the mean value of the distribution to determine a good representative unit weight for each nut categories. Then, using the unit weight we just estimated, I converted the distribution tally table into weight distribution table simply by multiplying the number of nuts in each sample by their respective unit weights. And from this, I calculated each nut. Once I calculated individual nuts by weight percentage in each sample, I plotted them on a histogram and calculated the mean and standard deviation for each nut category. I split this in an increment of 5 samples. When all 37 samples are included in the histogram, the weight distribution looks like the donut chart in the slide. On the weight distribution summary table, I recorded the mean percent weight of each category of nuts in the mix based on our sample size. You can see I calculated the means in 5 sample group at a time. I did this so I can answer how many samples it takes to yield realistic estimation. On the table below is where I converted the percent weight of each category of nuts into an estimated number of nuts in the total population, aka the whole can of mixed nuts, using the equation you can see next to the table. With only taking 5 samples into consideration while estimating, we get a huge error percentage in our estimate. One thing I found interesting is that hazelnut had a very little errors in estimation, even with only 5 samples. Majority of this has to do with how consistent the hazelnuts were in my can. On the other hand, the peanuts show the highest error percentage, and it has to do with how irregular the peanuts are. They are either whole nuts, split, broken, bigger, smaller, all shapes. So high standard deviation in their weight estimation, resulting in a high error percentage in the estimate. With 10 samples, errors do go down, but not where we want them to be. With 20 samples and about 40% of the population, all the nut estimations converge to reality, except for peanuts, and its irregular shapes is to blame for this. So yes, you can get close to the reality by estimating. That is, if you are up for counting pretty close to 50% of the nuts. Let me know, how would you approach this problem to get a better outcome in the comment section. Thank you for watching.